Let's learn about double replacement reactions. If we use a dancers on the dance floor analogy for understanding double replacement reactions, what we see is this situation. We have two pairs of dance partners. We have this pair, these are two particles that are bonded, and we also have this pair. This is a separate pair of particles which are also bonded. And in a double replacement reaction, one partner from each pair replaces the other. So what we're really seeing is something like this. So all these dance partners are really doing is just swapping, and now you have two new molecules. There's a number of important things to note about identifying a double replacement reaction. One of the most important is that in a double replacement reaction, you always begin with two pairs of molecules. And quite often these molecules contain what are called polyatomic ions. A polyatomic ion is a group of covalently bonded atoms that take on a formal charge. So for instance, nitrate is NO3 with a formal charge of 1-. And when you're showing polyatomic ions in molecular formulas, quite often you will see parentheses. So if you see a whole bunch of polyatomic ions and a whole bunch of parentheses at the start of a reaction, it might be a double replacement reaction. So let's head over to the lab and do a double replacement reaction. I'm going to demonstrate for you a double replacement reaction. In a double replacement reaction, you always begin with two ionic compounds dissolved in a solution, often water. When an ionic compound dissolves in a solution, we call that state of matter aqueous. So in an aqueous solution, you have a mixture of positively charged ions, those are called cations, and negatively charged ions, we call those anions. So in the example that I have here, I have lead nitrate. So I've got my lead, which represents the cation in this example, and the nitrate, which represents the anion in this example. And I'm going to react my lead nitrate with some potassium iodide. Now keeping in mind that this is a double replacement reaction, what products do you think we'll get when this reaction takes place? So let's do this reaction and see what we get. So I'm going to take some of my lead nitrate here, place it in my test tube. Now I'm going to take my potassium iodide and place that in. Let's see what happens. All right, so we see the formation of this beautiful, brilliant yellow precipitate. And keeping in mind that this is a double replacement reaction, there's really only a handful of products that can be. And this reaction demonstrates a pattern that we nearly always see in double replacement reactions. We always begin with two ionic compounds that are in the aqueous state. And then, when those compounds react, the ions that they're made of switch places, right? They kind of swap partners. And very often in the products, we get substances that are not aqueous. So we have a change in state of matter. So this yellow stuff is solid. This is lead iodide. Now the potassium nitrate is in there. We just can't really see it. It's just dissolved in the solution still. Often we'll see solids as precipitates. Sometimes we'll see the formation of water, as in an acid-base reaction. Sometimes we'll even see the evolution of gas. So that's our double replacement reaction. So in the double replacement reaction that we just saw in the lab, we took lead nitrate and we reacted that with potassium iodide. What we got was that brilliant yellow precipitate. So if we look at our dancers on the dance floor and think about what all of these particles were doing, over here we had our lead nitrate, over here we've got our potassium iodide, and what happened was the iodide came over here and kicked the nitrate out of the lead, and we ended up with the lead iodide as a product. Which brings us to one more important generalization about if you're trying to identify if a reaction is a double replacement. You might remember I said that in a double replacement reaction, you always begin with aqueous solutions. You have an aqueous dissolved molecule, an aqueous dissolved molecule. When a double replacement reaction occurs, you nearly always have a change in that state of matter. So in this case, we had the production of a solid that's called a precipitate. You can also have the production of a gas, or you could have the production of a liquid, such as water. The production of this different state molecule actually drives the reaction. It actually pulls the reaction toward the products. Now, if we were to illustrate our reaction we just saw in the lab between lead nitrate and potassium iodide, it might look a little like this. Here we've got our lead nitrate, and here's the potassium iodide. When they react, the iodide kicks the nitrate off of the lead and replaces it to produce lead iodide, and then the other product is the potassium nitrate. Now the potassium nitrate stayed dissolved in the solution, it was just floating around. So that's a great example of a double replacement reaction.